Okay, so good evening, everyone. So, any doubt or we'll solve the mock paper? Okay, so then we'll solve the
Yeah.
mock paper.
Will you
Yes,
solve the entire mock paper from start to finish?
yeah, we'll solve entire
Yeah.
mock paper.
Okay. Okay. Yeah. I had a few doubts, but that was from mock paper only. So yeah, it's fine. You can solve it.
Okay, okay. Okay, so my screen is visible, right?
Yes, sir.
Yes.
Yeah.
Okay, so in Anthem, there will be 20 question and there will be 20 question. 5 question will be true false question. So that will be like very easy. And there will be 15 MCQ, MSQ, and NAT. Question will be there, and most of the question will be NAT. From that 15 question, approx 5 question from combinational, approx 5 question from sequential, and 5 question, like this is also approx 5 question from CPU design pattern. So any doubt in format of the questions or any doubt in that?
No, sir. No, sir. You have already said this before. It's
Yeah,
fine.
yeah. So this time like some new people joined, that's why I assume on phone. Okay, now like let's solve uh, true false question. True false question will be like, it's like very simple, like combination logic is memory loss, right? So it will be true, right? And second question is, the dual of any boolean expression is equivalent to the original expression. It's false, right? So sometimes it's equivalent and sometimes it's not equivalent, right? So it's false.
So here there is a. I think we need to make a difference between Boolean expression versus Boolean equation. So if it is an equation, then it will always be true, right? The
It's
dual.
correct. So it will be like
But
boolean
in expression, it will not be true.
correct.
Right. Yeah.
Okay. And the 2 is complement on 4-bit system of binary number is one, like 1001 is 0110. So let's solve for finding 2 is like second complement, like 2's complement. You have to find the first complement, right? So first complement is just reverse, so 0110. This is the first complement, and you have to, for finding second complement, you have to plus one, so it will be 1110. So it's false, right? So now next question is, in a system 35 unique state, 5 flip-flops are sufficient to represent all states. So you have to find the log base 2, right? So you have to find the log base 2, log
Yeah.
base
With
2.
5, we can go up to 32 at max.
Yeah, with 5 we can go up to 32, so we cannot represent, like 2 to the power 5 we can go up to 32, right? So it cannot represent 35. Now like question number 5, in a like RS flip-flop, it will be not in the like syllabus, it's just one slide, so it's not in the syllabus, right? So will not ask in the anthem also. So it's just a question. I know it's like little bit like ambiguous is there in the internet something is there and in slide is something is there. So
Yeah, yeah.
this type of question will not be there. Don't worry.
But there is one thing though. I checked Morris Meno after Monidipa raised that issue that we are taking up from the slides only. I
Okay.
checked Morris Meno, but in Morris Meno, whatever professor mentioned, that is there. So zero zero
Yes.
in Morris Meno, it is given 0 0 is the forbidden state.
So basically we are following Morris Meno book. So
Yeah, yeah.
yeah. Okay. Okay. Now let's solve this question. Consider consisting of two D flip-flops, one NAND gates and one XOR gate as shown below. The initial states Q1 equal to 1, Q2 equal to 1. Then what is the numbers of possible state for the circuit when X in equal to 1? So we have to find the numbers of possible state, right? Okay. So when this will be equal to 1, then you have to find the numbers of possible state, right? So how to find that? So let's say current state or present state and the next state. And Q1, Q2 is Q1, Q2, right? And next state logic D1 is given as
Uh,
Q1.
Q Q1 nor sorry NAND Q2.
Okay, so Q1 dot Q2 NAND, right? And what will be the D2?
That's just Q1 bar, right?
Q1 XOR 1.
Yeah, Q1
Yeah, that
XOR
is the same
1.
as Q1 bar, I think.
Yeah. Uh, can you repeat, Barun or some?
Yeah, it's just Q1 bar, right? D2 becomes Q1 XOR 1 is just
Ah,
Q1 bar, right?
correct. Yeah. So we'll solve. Okay. Now Q1 equal to 1 and Q2 equal to 1. So initial state is 1, 1. So what will be like next state? You can see that D1 is it given, right?
It is
So it will be Q1 next. This is the Q1 next. So it will be 1 dot 1. It will be 0, right?
yeah, it will become 0 0 next state.
And Q2 will be Q1 is 1, 0, 1. It will be 0, right? So next is 0, 0. So 0, 0, you can see that 0 dot 0 complement it will be 1 and 0, 0, 1 it will be 1. So it will be 1. Again it will
Yes,
be so
states.
only two state possible. So yeah, this type of question will be come in the end term. So uh, yes. Any doubt in that question?
No, no doubt.
Okay,
No
one
doubt.
homework is when x in equal to 0, you have to find the numbers of possible states. Just try out. If you are unable to
Sorry,
solve, I'll
X in. Okay, yeah, got it, got it.
x in equal to 0, you have to find the numbers of possible states. Okay.
Sir, before we move on to the next question, just one doubt. I mean, in general, for these circuit type questions, we are
Mhm.
not to look at the color of the wires, right? They don't mean anything as such in the exam.
Yeah, will not look color of the errors.
Okay, okay.
Okay. Consider the circuit shown below. If you want to implement the same logic using two like cross one multiplexer or 2 is to 1 multiplexer, then what is the numbers of 2 is to 1 multiplexer required? So how to solve this question? Okay, so let's find this will be A bar B and this will be A bar B bar C, right? And this will be Y equal to A bar B plus A bar B bar C. So Y equal to A bar B plus A bar B bar C. No, you can take common A bar, right? So it will be B uh,
B plus C, right?
B plus B plus B bar C. Yeah. Okay. Now we can see that these things we can implement using like 2:1 marks, right? And these things will be like we can implement another 2:1 marks, right? So it will require 2. So let's design also.
So
So
this thing, right, b plus b bar c, you're directly saying that we can implement it using a 2:1 marks.
uh,
Can we arrive at that somehow without keeping it in like memory? Yesterday I tried to solve this, but I was stuck there, so I had to memorize that again.
okay, so
The formula
see,
for the 2:1 marks.
okay, so suppose this is a 2:1, 2:1, and suppose this is a, and suppose this is a B, and this is a select line S1. What is the formula? This is a suppose S. What is
Yeah,
the formula for Y? Y equal to
S bar A
um,
plus SB, right?
uh, S bar A plus SB, correct? Right, no?
yeah.
Okay, now like here you can see that this 2:1 multiplexer, this is 2:1. Here we can implement C because B bar C, and here we can implement 1. Suppose this is a B. What will get here? B bar C plus B, correct?
Yeah.
This thing we can implement only 2:1 multiplexer, correct? Now we have to complement A complement, right? So this, if we do like that, 2:1 multiplexer. Suppose this is a, and suppose they are 0. What will get? A bar B bar C plus B. You got it, right?
Yeah.
Yeah.
I had one question here, right? So A bar B plus B bar C, that we can simplify it further to A bar B plus C, right?
Uh-huh.
So for these type of questions, is that do you generally simplify or not simplify, or is that you have to go by intuition and just play around and see?
You have to go to intuition and you have to see all the things.
Okay, got it.
Okay.
We only have 2:1 multiplexer. No? Is there 4:1 or?
Then you have to see what is the 4:1 multiplexer formula, and you have to like design, like you have to fit in that 4:1 multiplexer.
4:1
No,
will
I
have
think
S1, S2 kind of thing.
Yes. So
no, I was saying that I think Cherian is asking whether or not we'll have anything beyond 2:1 in the exam for such expressions.
okay, so
Because
max we can accept 4:1 multiplexer. Max we can accept.
okay.
Yeah.
Actually,
Okay.
we tried to derive the formula for this 2:1 marks from the truth table yesterday, and
Okay.
then we were left with an expression that we could not simplify down. It
Okay.
turns out there is something called consensus formula. I mean, it's not part of the course as such. Turns out we
Okay.
have to apply that to simplify.
Okay. 4:1 the suppose this is S1 and suppose this is S2, and suppose this is a I0, I1, I2,
Right.
I3. So Y will be S1 bar, S2 bar, I0 plus uh, S1 bar, S2
S2
I1
I1 plus
plus
S1 S2 bar I2
S2 I2
plus S1
plus
S2 I3.
S1 S2 I3. So it's like simple.
Right. Okay.
Okay. So this question will solve later because this is a okay. Find the numbers of max term in the equivalent truth table function, right? So you have to find the numbers of max term, right? So you have to solve. So what is the A bar BC plus AB D bar, then CD plus C bar D bar, A bar B plus D, right? Okay, now let's solve. So you can see that A bar BC and A bar, so you can write A bar B C D, right? Plus, and you can see that the C and C bar, it will be 0, right? So don't have to write. Now at this A bar, we will get something, right? So you can see that A bar B C D, and you will get the same thing. So I'm not writing. Now here we get A B A B, then A B and A B, then C D bar, right? Correct. And here we will get like so yeah, I can see that sorry, you'll get, you can see that the D and D bar, it will be like 0, right? D and D bar, it will get 0, right? So I'm not writing. Now here you can say that you'll get A, then B, C bar, D bar. Now A bar plus B plus D, right? Okay, now that's solve. So we'll get same A bar B C D. Now you can say that like here, and it will get like 0, right? So I'm not writing now. These things A bar B C D will get something, right? A bar B C D will get something. Okay. Now you will get another A B C bar D bar, right? So only two min term is there. This is the min term. So numbers of possible, there are 4 variables, right? So numbers of possible equal to the 4 equal to 16, and there are 2 min terms. So max term will be 60 minus 2, it will be 40.
Sorry, I don't get this. Can you? So from the last step, where you got A bar, A, B, C bar, D bar. From then onwards, I haven't understood what you have done.
From which step up to that is got that is
Yeah, this is fine. Yeah. How did you get the last step? Can
okay.
you explain from that again?
Okay, you can see that A bar B C D, right? So you'll get something A bar B C D, you get something.
Yeah.
Now you'll get something A bar B C D, you'll get something, right?
Correct. Yeah.
And here also you'll get the same thing, right? A bar B C D,
Right.
correct. Now here A bar and sorry, this A and this A bar, it will get 0, right?
Right. Yeah.
So I'm not writing. And second we will get
B.
A bar
Okay.
B C bar D bar,
Right.
and last one is D and D bar, it will get 0, right? So we'll get only 2 min term, right?
Okay. Okay. Yeah. Yeah.
So there are 2 min term. So there are 4 variable, right? So total numbers of combination is 16, right? So
Right.
there are 2 min term. So 16 minus 2, max term will be 16 minus 2, 14.
Okay. Yeah. Got it. Got it. So you are like it's coming from the K-map itself. You have 16 possibilities and 2 of them are ones. Okay.
Not K-map, there are 4 variable.
Right.
A,
Yeah. So it will be a
B.
4x4 matrix. The K-map. I mean.
Yeah. Okay. Okay. So now let's solve this question. Consider the function given below f abcd, and it is given summation of 0 2 4 5 6 7 8 10 11 12 13 14 15. If you want to implement the minimized expression using only 2 input NAND gates, what is the minimum numbers of NAND gates required given inputs A, B, C, and D along with their complement? So you have to find the numbers of NAND gate required, right? So let's draw the truth table schema. right? So suppose this is a AB and CD 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0. This is 0 1 3 2 4 5 7 6 8 9 11 10 12 13 14 15. So it's given 2, right? So writing the black color. So 2 and 0 also is then 0 2 then 4 4 then 5 6 7 8 then 10 then 12 then 13 14 15, right? Okay, so you can see that uh, so you have to find that uh, these things, right?
Yeah, yeah, yeah.
If you find the POS, that will be very easy, right?
Right, yeah. It will just one
Yeah.
term.
Okay, so suppose so what will be the POS? Anyone? POS expression will be
It will be B bar. Wait. No, it'll be B D bar, I think.
so this is POS, not SOP. It will be plus, right?
Okay, so B plus D bar.
So you can see that D, right? So it will be like D bar, and here you can see that B, yeah, B plus
Yeah.
D bar, right? B plus D bar, and we have NAND gates, right? So suppose this is an AND gate. Now you can see that A, B, C, D along with their complement is available, right? So we can give B bar and D. So what will be the output? Anyone? B bar dot D whole bar, right?
Right, yeah.
So if you like apply De Morgan's law, it will be like B bar plus D bar. So it will be B bar plus D. So it will record only one NAND gates. Up to that is clear? Any doubt?
No.
Okay.
In the end, it should be B plus D bar.
Ah, yeah, sorry. Thanks. Someone. Thanks. B plus D bar. Okay. Okay, now consider a mod 15 down counters with an initial state like it's given. Like,
Based on the GA, I think. This
huh?
from 9 or week 10 GA.
So like whatever the mock is given, like try to like similar pattern like Anthem exam. So some question we have created new and some question we have took from GA and PA. Okay. So consider a mod 15 down counters with an initial state. It's given. What will be the state of the counter after 32 clock pulse? Like, so it's a mod 15 down counter, right? So after like you can see that 15 clock pulses. Again, it will be 0 0 0. After 30 clock pulses, again it will be 0 0 0 0. So 31 clock pulse, it will be like down counter, right? So it will be 1 1 1. 32 clock pulse, it will be 1 0. So answer is 1 0. Up to that is clear.
This question can be can run through the first few clock. Can do that.
Your voice is not
Yeah.
audible.
Yeah, yeah.
Mind-
Varun, your voice is no. I think Varun's voice is breaking.
Yeah, hello.
Yeah.
Clear now?
Yeah, now clear.
Yeah. The first clock, it will be decimal number 15. Therefore, it is 111, right?
I did not got your voice sometime break.
Yeah, it's breaking up actually. Can you type your question in the chat box maybe? I think it's a
That
network
will be
issue
good.
at your end.
Okay. So we'll take after.
Yeah, he's saying can you run through the first few pulses for this?
Okay, first few pulses. Okay. Okay, so first clock pulse, initial state will 0 0, right? So initial state 0 first clock pulse will be like down counter, right? So it will be triple, like it will be 15. Second clock pulse, it will be 110. Now third clock pulse, it will be this is 15, this is
1101.
13. So I think 1 101, right? This is 30, right? This is 8 plus 4 at
Yeah, I think this
yeah. Fourth clock pulse
1100.
1100, like that. Okay.
Right.
Okay. Can you show the next one though?
See, then 15th clock pulse will be value 1, right? I think I'm getting confused at after like what exactly. Can you run through the first 15 clock pulses?
Okay. Then okay, just I'm writing the fifth clock pulse. This is I think
You can
this
write
is
it in decimal, that's also fine.
this is 15, 14, 13, 12. Then fifth clock pulse it will be
Actually, 15 should
11.
not be valid if it's mod 15 down counter.
Yeah, correct. Okay, let's see, like sixth clock pulse. It will be 10. 7 clock pulse. 7 clock pulse, it will be 9. 8 clock pulse, it will be 8. And 7 clock pulse, it will be 7, right? And 7 clock pulse, then 6 clock pulse, it will be 6.
I think you're getting the clock pulses wrong. So 4th, 5th, 6th, 7th, 8th, and 9th and 10th, right?
Okay, 9, 10. Okay, sorry, 9, 10, 11, it will be 5, 12, it will be 4, 13, it will be 3, 14, it will be 2, and 15, it will be 1.
Yeah, I think we should not start at 15 then.
I can, you can see
Zero.
that after, so after 15 it will be 0 0 0, right? Initial
So that will be 16th clock pulse.
correct.
Right. Yeah.
Correct. So, yeah, I think your doubt is clear, right?
So wait, so at the 15th clock pulse, the decimal value is 1, right? So it will be 0001, correct? Then
No.
at 16th, sorry?
Okay, so yeah.
Actually, sir, it's a mod 15 down counter, so 15 won't be the value. The first down count will be go to 14.
14. Yeah. If you start from 14, then the 15th pulse will be 0, as you have written down.
Oh, got it. So, right. So in the first clock pulse, it should be 14, correct?
First clock pulse it will be. Correct. Yeah. First clock pulse it will be 14, I think. Yeah.
Because 15 is divisible by.
Yeah. 0 to.
It's
Yeah.
mod
0.
mod 15, right? We cannot have 15 in the values possible values. It will be 0 to 14.
It will be. Yeah. Like we'll see an answer in the Discord. That will be good. But this is a little bit confusing. We'll see an answer in the Discord. That will be fine, I think. Right?
Yeah, okay, sure.
I think,
Can
yeah.
you when you post in Discourse, can you also put in that maybe if it is a mod 15 down counter, can you put in the first 15 or 16 pulses?
That I'll like if I put in the Discourse, I'll be like explain in detail. Don't worry.
Okay.
Okay. Right.
This question was asked in quiz 2, right?
This question is not quiz to. This is, I think, graded assignment.
Oh, okay.
So consider the circuit diagram as shown below. Assuming it was initially cleared to 0, state the output Y for the next 4 clock pulses. Right. So you have to find the next 4 clock pulses. Right. So JK flip flop truth table is, suppose this is a Qn plus 1. So if 0 0, it's Qn. If it is 0 1, it will be 0. If it is 1 0, it will be 1. And if it is 1 1, it will be Qn bar, right? Okay. So now let's solve that question. This is a present state and present input. And next state.
Here, I just have a small doubt.
Okay.
Right, these numbers inside the flip flops, right, 0 and 1. They that means the current value of the flip flop, correct? What it's outputting.
Yeah, it's current value. You can see that, like, and the question also mentioned assuming it was like initially cleared to 0. So initially, like, we can
No,
say that,
but-
like,
But how? Okay, when it's cleared to 0, that means the box inside that should be 0, right? Inside the D flip flop.
so sometimes, like, taking the screenshot, maybe like 0.
Acha, okay, got it.
Yeah.
So when the question it mentions that assume it was initially cleared to 0, that means the flip flop is currently outputting the value 0, correct?
Correct.
Okay, so if something is mentioned in the question, we take that over whatever is there in the screenshot. If nothing is mentioned, then the screenshot is what we should assume, right? The values
Yeah.
in the screenshot itself. Okay.
Yeah, correct. Okay, so you can say present inputs is like 0. Like present state is like whatever the Q1 is 0, then present inputs. So J1 will get Q1 bar, right? So it will be like J1 and this will be the Q1. So it's 1 and it's 1. So when it's 1 1, like, it's Qn bar, right? So it will be 1. Now it's 1. Now we can see that J1, like, it will be J1 will be 0 because Q1 bar, and Q1 it will be always 1. So 0 1, it's 0, right? Now it's 0 again, it will be 1 1, and it will be 1. So you can say that it's repeating, right? So 1 0 1 0, it will be 1 0 1 0. Okay, so this is clear, right?
Yeah, this is clear.
Okay. Now next questions. Consider the circuit as given below. Identify the type of counter shown in the above circuit. So you have to find the type of counters shown in the above circuit. So let's suppose this is a present state. So first you have to find the what will be the value of q1 and q2, because you can see that this is the function of q1 and q2, right? So first we'll find the q1 and q2, then we'll find the what is the ms like printing. So this is the present state, and this is the next, right?
So
This will be
Q1 equal to Q2, right?
q1 q2 q1 q2. So first we have to find the whatever the value of q1 and q2.
Right. So Q1 will be equal to Q2.
Yeah, not q2. Why q1 will be equal to q2?
I mean, that is what is coming into the D1 flip flop, right? From D2 the output, that is
No,
Q2.
it's given like q1 next, or given q2. Yeah, it will be like q2, and q2 next or d2 will be, it's given q1 bar, right? Okay, so let's
Right.
start from 0 0. So 0 0, then you can see that q2, so q2 is 0, right? So q2 and q1 next, and next q2 equal to q1 bar. So q1 bar it will be 1. So 0 1. When it's 0 1, you can say that q2, so it will be 1, and it will be q1 bar. So 0 1, it's 1. So now 1 1, it will be 1, and q1 bar will be 0, right? Then 1 0, it will be 0 and 0. So up to that is clear.
Yeah.
So it's basically like depicting 0 1 0 0, then 0 1, then 1 1, then 1 0, then 0 0 again. Okay, now it's when it's 0 0, what's printing? When it's 0 0, you can see that this must be like, this is a, suppose a, this is b and c. So a equal to q1, so this is equal to, suppose q1 and q2, q1 q2, q1 q1 q2, and q1 q2. So a b c, so a equal to 1, so it will be 0. And what is the value of q2? What is the value of b? You can see that b value is b equal to q1 bar plus q2 bar, correct? q1 bar plus q2 bar.
Yeah. I was speaking on mute. Sorry. Yeah.
Okay, so q1 bar plus q2 bar, so it's 0, bar will be 1, plus 1, it will be 1, right? So it will be 1. And what is the value of c? C, you can see that q1 plus q2, right? C equal to q1 plus q2, correct? Q1 plus q2, correct?
Yeah. That's correct.
So c will be 0 plus 0, it will be 0, right? So first is 0 1 0. Now here a equal to q1, so it will be 0. B equal to q1 plus q2 bar. So again 0 bar equal to 1 plus 0, it will be again 1. It will be 1. And what will be the value of c? C equal to q1 plus q2, again 1. So 0 1 1, right? Now when it's 1 1, so a equal to q1, right? So it will be 1. What is the value of b? B equal to q1 bar plus q2, right? So b, q1 bar plus q2 is 0. And what is the value of C? C will be 1. So it will be 101. And when it's 10, A equal to 1 and C equal to like B equal to Q1 plus Q1 bar plus Q2. So 1 bar equal to 0 plus 1, it will be 1. What is the value of C? Q1 plus Q2. So it will be 1. Right, it will be 111. So you can see that 2, this is 3, this is 5, this is 7. So you can see the 3-bit prime up counter. This question is clear for everyone?
Yes.
Okay. Now the next question. Let a processor contain 8 registers in a register file. Consider that the ALU is capable of performing 4 different operations: addition, subtraction, and NOT. How many bits will the instruction contain in order to perform addition between 2 operands and stored in the register file? So you have to perform A plus B and stored in the like another file, right? So C equal to A plus B, right? So you can see that for there are 8 registers, right? So for identify like each register, you have to find 3 bits, right?
Right.
Now you can see, so you have to perform addition between 2 registers, right? So there will be 2 registers, suppose A and then B. So it will record 3 bits, like I'm writing
Yeah, so
like that.
6 bits for the registers, for the input registers.
And for the storing, it will be like again 3 bits, right?
Right, so 9 bits.
And for like performing which operation, there are 4,
2 more
1, 2,
bits.
3, 4, 2 more bits. So which operation?
Yeah, the
Will be 2
opcode.
bits. Yeah. What will be the opcode? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that will be 11. Up to that is clear?
Yeah.
Okay. Okay, now 15. Let a processor contain 16 register file. Consider that the ALU is capable of performing 5 different operations: addition, subtraction, and not XOR. Consider the following instruction given: move AB, add CD, not A. What is the sum of total numbers of bit required to represent the various registers? So we asked like total numbers of bit required to represent the various registers used in the given instruction in the respective controller, right? So how many total numbers of bit required, right? So only register, right? So you can see that there are total 16 register, right? So that we require 4 bits. So move AB. So only register there will be A and B register, right? So it will take 4 plus 4 equal to 8 bits here. Add CD, here will be 4 plus 4, 8 bits. Not A, only one register. So it will be 4. So total numbers of registers required 8 plus 8 plus 4. It will be 20. Okay.
Okay.
So
Sir,
just one thing. Peter, if you go first.
yeah,
Yes.
I just wanted. Can you scroll up to the previous question? I just want to compare the last line of the 2 questions. One is asking for the bits, like how many bits the instruction will contain, and
Uh-huh.
the other one is asking for how many bits for the registers in total, like for all the 3
Correct.
operations.
Correct.
Okay, okay. I think it's yesterday we made a mistake while we were trying to solve this. We included all the operations as well within this.
Oh, okay. So just like we
Okay.
are asking this.
So for this one, I had answered 16 because there are just 4 registers.
Uh-huh.
So we don't need to do unique here. Like even if it's repeated, we have to sum it up because we only have 4 registers, right? A, B, C, and D. So we would need 16 bits to represent the various registers, correct?
You can see that there are 60 registers. So like there are 4 bits required, like for identify each register.
Correct.
So move AB. So here it's like 2 register required, right? The controller will be
Correct.
like 8 bits. Here move AB 8 bits required.
Mm-hmm.
Add CD here 8 bits required. There are 2 registers.
Mm-hmm.
Note A, there is 1 register, so there are 4 bits required.
Right. No.
But
I
we have
follow all
already.
those calculations. I'm saying
Okay.
we have already included A. That's why I had summed up only
Right.
A, B, C, and D. So I had answered 16 for this. Do you
Oh,
understand
oh,
where I'm getting that confusion from?
Yeah, there is this
okay.
ambiguity in the thing here.
Okay.
I mean,
Because what is the
are
sum
we
of the
supposed
total?
to take it unique
Yeah.
in a unique manner, or just sum all of them?
Okay. So yeah, correct. Okay. Any doubt in that question, or shall we move forward?
If a similar question comes in the exam, I should assume that I have to sum up everything, right? Even if it repeats.
Correct.
Okay.
And like, don't worry, like in end time exam, like whatever the question is, like I think all the question is like it's reviewed like multiple times. So this type of ambiguity will not be there in the end time exam.
Okay.
Okay, this like this we have prepared like last minutes. You asked like we need mock, right? So that's why we
Yeah.
have prepared last time. Okay. Yeah, I can understand your doubt is also valid. Okay.
In that same question, if it was how many bits are required to represent the instructions, the answer would be you have to just add 3 to every row.
Correct.
Okay.
Because there are 5 operation is there, right? So 3 bits. Yeah. Okay. Suppose you want to execute data movement instruction where we move the data. So where we move the data present in register R30 to R23. Instruction move RDR, right? So RD destination register, and this is a source register, and operands are given 0 to 31 and 0 to 31, like destination and source register. So instruction formats are given like that. Following the same instruction format, consider the following 16-bit opcode. What will be the source and destination registers respectively, right? So you have to find the source register and the destination register. So let's find the destination register first. So here you can see that this is the destination register. So here it will be 1. So it will be 1. Here is destination register. So it will be 0. Here it will be 0. Here is destination register. So it will be 0, and here is 1. So 1 0 0 1. So what will the value of destination register? This is 16. This is 1. So it will be 17. So RD will be 17. Now what we have to find the source register, right? Source register is, you can see that this is the source register. So this is the source register. So it will be 1. This is the source register. This will be 0. This is the source register. Last one is 101. Again 0 and 0. So we have to find the, so this will be the 16. This will be the 8. So 16 plus 8. 16 plus this is 4, right? Yeah, this is 4. So it will be 20. So RR will be 20. So this option will be correct. Okay. Next is, if we implement a simple memory array with an address space is 32 and total size of memory is 256, right? So what
We
will be
just
the
divide.
address? Yeah. Yes, Pritadeep?
Yeah, I'm saying we just divide. So 256 by
Yeah,
32. That's the answer.
yeah, correct. It's like simple thing. So total bits required.
I think this is the same question that was asked in graded assignment 10. It's just flipped around. It's,
Correct.
in GA10 we were asked to multiply. Here we need to divide.
Correct. So it will be 8 bits. Okay. Now consider the given data for the next 2 questions. So consider a common bus architecture comprising of memory, register X, Y, and Z. The control word format is given below. So this is the memory, this is register X, register Y, and register Z. What will be the control word if you intend to perform a register transfer from register X to register Y? Right? So if you want to intend to perform register transfer from register X to register Y, right? So what will be the control word? Suppose this is a memory. So I'm writing here. I'm writing here. So what will be the control word? Suppose register X to register Y. So this will be 0, this will be 0. Input will be 0,
Zero
output will be,
output will be 1.
and register Y input will be 1 and output will be 0, 0, 0. So it will be 0, 0, 1 and this will be 8. So it will be 0,
0
X,
x
1. Okay, now next question. Which of the following control words does more than one register read from the bus? So you have to find the which of the following control word does read from register from the bus. So just write the control word here. So memory.
So for these questions, we'll have to just look at the options. No other way of doing it, right? You have to solve all the
Yeah.
options and check.
Yeah, correct.
Yeah.
Right. Read, then write. Register X, register Y, register Z. Right. This is the input output. Input output. Input output. Input output. Right. Okay. So 0x A0 means A means anyone? What will be the value of A?
It's
A
10,
means
right?
10, right?
10.
1 0 1 0 1 0 1 0 and 0 0 0. Okay, so it's only one register read from the bus, right? Only register X, right? So this will be the wrong. Now let's find second one. 0x88. 88 means 1 0 0 0 1 0 0 0, right? So yeah, it's like
Is
more
this one
than one.
valid?
Yeah, I think this one is valid. Okay, yeah, because register Y and register Z also reading from the bus. Yeah, this is valid. Okay, this is valid. Okay.
So if memory is reading into it, then we also consider that a register being
Memory
read.
is like read means like it write to the bus, right? It's like memory is read means like write to the bus, right? It's taking from memory, right? Okay.
Yes.
Yeah, but in that case, then this should not be. I mean, the second option should not be correct, right?
Why?
It's saying you're reading from the bus.
Okay, it's read from the bus.
Sorry, I'm confused. Can you just explain this option once again from scratch? I'm just confused with this.
See, you can see that read from the bus, right? So, okay, let's see here. Suppose there are. This is the memory. We cannot write into the memory, right? So this is the memory, and suppose this is a register X. Register Y, register Z. So there is memory read and write. Read means like uh, whatever the bus like bus will take data from read like from memory, right? Whatever the memory content, it will take data from memory like memory. And write means like whatever the bus content, it will write to the memory. It's correct. Like it's you got it, Pritadev, right?
Yeah.
Okay. So one means like that bus will read from memory, right? So this is also
Right.
valid. Okay. Now,
No, but it's not reading from more than one register, right? It's reading
oh yeah,
from the
yeah,
memory, no?
yeah. So it's only I think only Y,
Yeah.
only Y like read from the bus. Sorry. Yeah. So this is the not valid option. Okay.
So is the code that you have written itself? Can you check that once again? Is that correct? 1000.
Uh,
It's 888, right?
This 8. Yeah, one. This is 8, right? And this is 8.
Okay. Yeah.
Yeah.
Just to clarify, right? So
Mhm.
when the read is 1 for memory, that means the memory is writing to the bus, correct?
Not memory starting to the like bus is taking data from
Reading
memory.
from
Yeah, taking reading
yeah,
from memory. Yeah.
bus is reading from memory, and when the write is 1 for memory, that means bus is writing to the memory, correct?
No, memory is like taking data from bus.
Yeah, okay. I said it the other way around. Bus is writing to the memory versus memory is
Yeah.
taking data. Okay, got it. And when input is just 1 second, when input is 1, that means register is taking data from the bus, correct?
Yeah. Yeah. Correct.
Okay.
Okay. And on output is 1. So bus is taken data from register.
Okay.
Okay. So one is A means like 1 0 1 0 1 0 1 0, right? So you can see that more than one register. So register X also read from the bus and register Y also read from the bus, right? So this option is correct, right? 0x8. So 8 means 0 0 0, right? So you can see the register X and register Y also read from the bus. So this is the correct option. So 2 are the correct option. I hope you got it right.
Yeah.
Yeah.
Okay, and this is the simple question. Consider the following instruction be performed in this exact order inside processor: Rx equal to Rx plus Ry equal to Rx minus Ry, and Rx equal to Rx plus Ry. Here Rx and Ry are registered contain initial value of 36 and 14 initially respectively. What will be the value of Rx at the end of the all three instructions, right? So Rx is Rx plus Ry. So Rx will be 36 plus 14. So it will be 46 dosh like in, yeah, 50. Then Ry is Rx minus Ry. So 50 minus 14, it will be 36. Rx equal to Rx plus Ry. So 50 plus 36, it will be 86. So answer will be 86. Up to that is clear.
Yeah.
Okay. Okay, I think one question is left.
That is the most difficult one.
Not difficult. It's like very simple.
No, it's extremely complicated. If you make one mistake, then the whole thing is gone. If I have like, I think
And-
we almost spent almost 1 hour on that yesterday.
Okay.
And
So
even this,
you are doing
yeah,
group
you
study
can
or
you can go ahead.
you are doing group study or
Sorry?
you are doing group study in meeting or something?
Yeah. For the mock we did. Yeah.
Okay, great. Okay, so this answer will be I think 4. It's written like this will be 4.
Yeah.
Okay, so design a circuits with output F.
Wait, is
And
it 4?
it's 4.
Yeah.
It will
Okay,
be 4.
then. Oh wow, all the work we did yesterday was wrong.
So yeah. Design a circuit with output F and inputs x1, x0, y1, y0. Let x equal to x1, x0 be a numbers where four possible values x 0, 0, 0, 1, 1, 0, and 1, 1. Represent the four numbers 0, 1, 2, 3 respectively. Similarly, y equal to y1, 1, 0 represent another numbers with the same four possible values. The output F should be 1 if the numbers represented by x and y either both are odd or both even. So if both odd or both even, then you can like 1, right? Otherwise f should be 0. So if we want to implement the above logic using only 2 inputs NOR gates, find the minimum numbers of NOR gates required, right? So better to like draw the first draw the truth table, right? So this is x1, this is x0, this is y1, this is y0. So I don't think it will be right, and this is the f. So 1, 3, 4, 5, 0, 1, 2, 3, 4, 5, 6, 7, 8. One, 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 0, 0, 0, 0, 1, 1, 1. Then it will be 0, 0, 1, 1. It will be 0, 0. It will be 1, 1. It will be 0, 0. It will be 1, 1. It will be 0, 0. It will be 1, 1. 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. So the output f should be 1 if the both the output f should be 1 if the number respectively by x and y either both are odd or both are even. So if both are odd or both are even, then it will be 1, right? So you can say that this will be 1, right? Because both numbers are even. Hello.
Yeah, but I think we don't even need to go through the truth table. No, we just have to recognize that x0 and y0 have to be the same, correct?
Yeah, so y will be like x0, y0. If you simplify and
It's
if you like
x0, x nor y0, right?
yeah. So y0. So it will be y equal to x nor y0, right? So this will be the like if you like see the SOP, so it will be like y equal to x naught y0. So if you like just fill the truth table for your 0 0 0 1, it will be 0, 0 0 1 0, it will be also 0, and you can see that 1 is even, but this is odd, it will be 0, 0 1 is also 0, 0 1 0 1, it will be 1. So that like you can fill the truth table. So final expression will be y will be x0 y0 plus x0 bar y0 bar. This will be x nor x0 x nor y0, right? So the numbers of NOR get required, it will be 4. With the help of 4 NOR get, you can represent NOR get, right? So circuit expression will be like that. This is sorry, let's this is x0, this is y0. So you'll get the x nor x0 x nor y0. Okay, so any question in this, like in that question, any doubt?
Yeah, see, I got the solution after like I spent a lot of time. I couldn't get the solution. Then I just Googled how to do an XNOR gate using NOR gates. I'm
Okay.
just wondering if this comes up in an exam, like a question like this, how should I go about solving it?
This
Yeah.
Because I I would have never recognized thinking about this pattern, right? So I'm just wondering if there are any tips or tricks to go about solving these questions if we don't know, like this is the
See,
pattern it follows.
see, I think I explain like how to like you can like derive, you can derive
Using De
like
Morgan's law.
yeah, like there are two universal gate, right? One is NAND gate and one is non-core. So I think one live session like I derived how to like NAND gate, how to derive JOR gates, and like XNOR gate also, and from NOR how to derive JOR and XNOR. So basically, like you can remember like for NOR gate, if there is NOR gate, you can implement like 4 NOR gate, you can implement XNOR gate, and with the help of 5 NOR gates, you can implement XNOR gate. Sorry, JOR gate. JOR gate. This is XNOR. And with the help of 4 NAND gate, you can implement JOR gate. And with the help of 5 NAND gates, you can implement XNOR gate.
So have you? I don't remember which session though. Have you done all this expression? Have you simplified the expressions and got it that way in the live session you're talking about?
Yeah, correct. I think second or
Which
third week,
session?
second week or third week. I think I did not remember. I think third week.
Okay, okay. If possible, if you remember that, can you link it in the chat space or
Yeah,
something?
I'll give the link. I'll give the link.
Okay.
That is like that is enough for your anthem. If you remember, that is enough for your anthem.
No, that okay. So the problem is, I mean, this is very simple. I mean, if you just give a, I mean, whatever expression we get, if it ultimately simplifies down to either an XNOR or an XOR gate, we can
Uh-huh.
directly mention the answer. But what if it is a mixture of the two? If it is like XOR plus something else or XNOR
No,
and
will not ask. That will be like very difficult. So will not ask.
okay. Then that is good. Okay.
Okay.
Actually, the thing is, we got this expression x1 y1 plus x1 bar y1 bar. We were able to reach till this one, but
Okay.
simplification that we did, it led us to five five gates. But then again, I think that is also a reinforcement because we saw the answer is 5, so it is possible
Oh,
we were
okay.
not even trying to simplify it further.
Oh, okay. Okay. So I think like by mistake given 5, it will be 4.
Okay.
Okay. So any doubt? Any question? This counter question, I'll create one post in the discourse and share you.
Yeah, the
Okay.
clock pulses. Also at the
Clock
clock
pulse.
pulses.
Clock pulses question. Okay. Any doubt in any questions?
I have a doubt. I mean, general query. The GA11.
Hmm.
Can we has that been evaluated yet? The circuit
Yeah.
bus.
Yeah. It's like evaluated.
Okay.
So
Okay. Marks
there
has
will
not
be
been
like
released. So
yeah. So I think 5 plus 5, it will be like 10. So this subjective question will take 80%, and whatever the objective question will be there, will take 20%. So it will be 100%.
okay. Okay, but the marks for this one will be released before the end term, is it? Or it will be
It will
after
be
the end
released.
term?
So I saw your marks. You will get. I think you got 10 in the subjective, and Cherian also like.
Okay. Okay. Fine.
Okay. So any doubt?
Yeah, I was wondering, will there be any questions from the week 11 and 12 on micro instructions or timing state and all that?
No, there will be no such question.
Okay.
Basically, like we'll cover like up to max up to week 11. Like complement and all the things like 2's complements, 1 complements.
Okay.
Okay, so all
And,
the best.
Sir,
Yeah.
the PDFs for the GS and PS, the remaining ones, I think week 9 and later.
Yeah, week 10, 11 is up to date, I think.
Okay, okay.
Week 9 is there, so I'll upload maybe by tomorrow. That will be good.
Okay, sure.
Okay.
And
slide
one
also,
thing, yeah, okay.
slide also will upload by tomorrow. Don't worry.
Sure, sir, sure. I just wanted to clarify one more thing. You had said initially that for the end term, except for true and false, every other question will be for 3 marks. I just want to clarify that is indeed the case.
Yeah. Every question will be 3 marks.
Okay, okay, good. Yeah, this is much
So
better than quiz 2.
yes.
And is that relative grading or absolute grading?
See, sir, we are planning not like yet decided. So we maybe like do relative grading like overall marks, whatever you got. Not end term, overall like quizzes plus quiz 1 plus quiz 2 plus end term plus the graded assignment. So maybe
Sir
like
mentioned this earlier that it will be, if it is relative, then it will be based on the total course score. It won't be for the end term score alone.
not will be end term, it will be overall.
Yeah. So the total course score, I think the entire
Yeah.
thing.
Whatever the T score is there, I think.
Right, right.
Yeah.
Okay. Thank you.
Okay. So all the best for your end term exam. So I'll create one post in the Discord so you can give your feedback, like course content, about the live session, about the professors, about the instructors, and all the things.
Yeah.
So I'll
After
suggest
the end term,
please
though.
give
After Sunday.
our course content.
Yeah. Sure.
Okay. Okay, then all the best for your end term exam and good night, everyone.
Thank you, sir.
You.
Good night.
Just
Can
the
you share
mod
the link?
counter one.
Can you share the link to this recording in the chat space, or can you upload
Yeah,
it
I
to
will
check?
share the recording. Don't worry. Yeah.
Okay.
And the mod counter thing on this course.
Yeah, yeah. I will like after the session, I'll take dinner and after that I'll post in the Discord.
Okay. Thank you.
Okay.
Thank you.
Thank you, sir.
Okay.
Good night.
Okay. Okay. Bye.
Thank you.
Good night.
Thanks for the mock.
Yeah. Thanks.